Good morning, Math 186 friends. Welcome to Pre-Calculus via YouTube. All right, so looks like about 2 weeks ago we were finishing up Chapter 7. We didn't get to 7.6, which is solving trigonometric equations. This is a long section, so the lecture will probably need to come to you in 2 or 3 parts. So first, before we start solving trigonometric equations, we have to do a review of our basic algebra. Factoring review. So it's a matter of just associating factoring in algebra with factoring in trig. What if I asked you to factor x squared sorry, I was shaken, minus x minus 2. The answer would be, well, we have something squared minus 1 times that something minus 2. What we're squaring here typically goes first in the parentheses because the product of the first is the first. We're looking for 2 values to put here such the product is -2, but then the inners and the outers will give me -1. So because of our experiencing with factoring, we know that we can factor x squared minus x minus 2 to x plus 1, x minus 2. Product of the first is the first, product of the last is the last. Inners give me 1x, outers give me -2x for the needed -x in the middle. So now keep in mind that this works. If you had me for Math 137, I would always do weird things like this. If I did something squared minus something, minus 2, as long as what's here and what's here are the same, that this is just that one being squared, we can factor, and it would just be that goes here, the star goes here, we still can do the +2 and the -1, and we check the product of the first is the first, the last is the last, and the inners and the outers give me the star in the middle. All right, so how does that apply to what we're talking about now? Well, we are now factoring trig equations, and the next step after factoring, we'll be using our factoring to solve our trig equations. So what if I said factor sine square root of x minus the sine of x minus 2. So if you notice, this just follows the format of the last couple of problems because this is something being squared, so we're squaring the sine, so that corresponds to our star, minus that one of those things, minus the constant 2. So the answer would just simply be, what goes here would be what's being squared, sine and sine. So the product of the firsts would can be sine squared, the last, plus 1 minus 2 will give us the -2. Then we have 1 sign in the middle, minus 2 signs on the outside, give us the minus sine x. So now so this is what you have to look for. You have to look for patterns. This should be the same as this. It's not always going to be. Sometimes we're going to need to make some substitutions to make this work. But right now, the basics, this is just that thing squared. So it's no different than these 2 previous problems. All right, so keep that in mind, factoring trinomials. What if I asked you to factor this? X squared minus 1. Well, you may notice this is the difference of squares. So x squared minus 1 squared. So the answer would be x minus 1, x plus 1. Remember these conjugate expressions, the inners and the outers cancel. Difference of squares, hopefully you're comfortable with factoring that. So keeping that in mind, if you see something like this, factor sine squared of x minus the tangent squared of x. Notice this is just the difference of squares. It's the sine being squared, and we're subtracting the tangent being squared. So, difference of squares. The first minus the second. The first plus the second. Oops, sorry. There we go. Product of the first is the first. Product of the last is the last. The inners and the outers cancel. Okay, difference in squares is always important. Remember, anytime you have something squared minus something else squared, can always be reduced to this. You might say, well, that looks like more than less. What we did is we reduced the power. So instead of working with sine squares and tangent squares, we're just working with regular sines and regular tangents. And that will make our problem solving much easier. All right, don't forget, what if you were asked to factor something like this? B cubed minus b squared minus b plus 1. Now back in Math 137, we were taught that anytime we saw a four-term expression that could not be simplified, to try grouping. So in other words, group them in pairs. You can only group when you have an even number of terms. So if we look here, we see that these two terms share b squared. And if we pull the b squared out, we get b minus 1. So we want this to look like b minus 1 here. And is there anything we can pull out? Well, the coefficient of b is negative. We want to change that to a negative 1. So I can pull out b, the negative 1 from the second term. Now these two chunks share the b minus 1. So I can pull the b minus 1 out front. When I pull the b minus 1 out front, what's left is the b squared minus 1. So b cubed minus b squared minus b plus 1 can be factored into b minus 1, b squared minus 1. So notice the goal of factoring is to reduce the powers on the expressions, on the polynomial pieces. So we started with the cubic, we reduced it to a linear and a quadratic, but notice this is not completely factored because b squared minus 1 is the difference of squares, and that can be written like this. So that would be b cubed minus b squared minus b plus 1 completely factored would be b minus 1 times b plus 1. Right, so now keeping that in mind, we're going to apply that. We're just going to replace the b's with trig functions. So let's suppose instead of b, I had cotangent cubed. And instead of b squared, I had cotangent squared minus the cotangent plus 1. If we follow the same format, all four terms have nothing in common, but this is not a prime polynomial. It can be factored. So four-term expression is often screaming to be grouped. Here we can pull out the cotangent squared, just like we pulled out b squared up here, and what would be left would be the cotangent minus 1. Now we want this, in order for the grouping to work, this has to have the same term cotangent minus 1, so we can pull out the minus 1. Now we notice that they share, just like they shared, the upper expression shared the b minus 1, b minus 1. This shares the cotangent of minus 1, so we're going to write this as the cotangent of x minus 1, and then what's left is the cotangent squared minus 1. And then this is the difference of squares. So just like we're following this format here, instead of b's, we have cotangents. Cotangent of x minus 1. And then this piece is the difference of squares. Cotangent of x minus 1. Cotangent of x plus 1. Boom. All right, so this definitely takes practice. So this is leading up to solving equations. We're going to need to factor expressions in order to solve equations. All right, another reminder from our factoring days. The square root property. Whew, sorry, I was just looking, it didn't look like I was recording. Square root property. The square root property simply says if something squared equals a number, then that something is equal to the plus or minus square root of that number. So this concept is really super simple when we just use variables. So for example, if I said to solve x squared equals 81, then the answer would be x is equal to, so something squared equals a number, then what we're squaring, which is x, is equal to the positive or negative square root of 81, which would be positive or negative 9. And negative 9 squared is 81, positive 9 squared is 81. So therefore, my solutions would be x is negative 9, positive 9. We know Alex likes our solutions separated with commas. Solve. What if I said x squared equals 50 instead? Well, the answer isn't as obvious as 81, but if we apply the square root property says if something squared equals a number, then that something is the positive or negative square root of that number. And don't forget from algebra, we need to simplify all radicals. Square root of 50 is not simplified because 50 has a perfect square factor. So this is plus or minus 5 square root of 2. So therefore, my solutions would be x is equal to negative 5 square root of 2 and positive 5 square root of 2. So how is that going to help us in this section? Well, in this section, we're going to be asked to solve things like this. Solve, and it gets quite more complicated. Sine square root of x equals 1. Okay, so think of this as the sine of x squared equals 1. So we have something squared equals a number. So we can apply the square root property here. What I'm squaring is the sine. So if the sine squared equals 1, then by the square root property, the sine of x equals the positive or negative square root of that number. So in other words, the sine of x is equal to the positive or negative square root of 1, which is 1. Now, unfortunately, it doesn't end here because if we're solving for x, we need to find the angles that satisfy this criteria. The sine of what angle is equal to 1? The sine of what angle equals to negative 1? So now I'm going to break this down into two smaller problems. We need to find the values of x such that the sine of x is equal to 1, or the angles x, or the sine of x is equal to negative 1. If you remember your unit circle, or if you use your trig hand, the sine is equal to 1 when we have our angle over here. So x is going to be, it's any angle whose terminal side lands on the positive y-axis. Would be the sine equal to 1. And over here, the sine is equal to negative 1 anytime we have an angle whose terminal side lands on the negative y-axis. All right, so we have to include, so the first angle whose terminal side lands on the positive y-axis is pi over 2. Okay, but it could also be this angle, and it could also be that angle. So any angle coterminal with pi over 2, we add the all multiples of 2 pi. Over here, we're going to get, you could use negative pi over 2. We tend to use the angles between 0 and 360, or between 0 and 2 pi. So I'm going to use my positive angle there, although there's infinitely many different ways you can write this. And all angles coterminal. So this says 90 degrees and all angles coterminal with 90 degrees, pi over 2, and all angles coterminal with pi over 2. Here we have 3 pi over 2, or 270 degrees, and all angles coterminal with 3 pi over 2. So this original equation, whoops, where are we? Right here, sine squared of x equals 1, we're looking for angles such that when we square the sign, we get 1. And there's infinitely many solutions. All angles coterminal with pi over 2, and all angles coterminal with 3 pi over 2. We have to be careful though, because sometimes the question will say find all solutions, or it'll just say solve. In that case, it's looking for all solutions. Careful, the question may be worded like this. Solve sine squared of x equals 1 for x in 0 to 2 pi, or something along those lines. So in this case, it'd be the same solution here, would be looking for all angles whose sine is 1 or whose sine is -1, but we're only looking for angles whose initial side starts here and whose does not exceed 2 pi. So of all the solutions, the only angles between 0 and 2 pi would be pi over 2 and 3 pi over 2. So it's not looking for all the angles, it's just looking for the ones between 0 and 360 degrees. All right, let's see. All right, I'm pushing my limit, so I'm going to end this one here, and I will pick up in solving trig equations part 2.